Hello, everyone. This is my first stream on Facebook doing this. So if it doesn't work, uh, I will be talking to myself for the next 5 or 10 minutes. So let's just get right into it. Today is April 21st, 2024, and there's going to be an earthquake watch period coming up. So I'm going to walk you through what I'm looking at and how I come up with these times and locations and stuff. So first of all, we start here at SDO, which is a Solar Dynamics Observatory. This is a free resource. It's from NASA. It's a .gov website. Anybody can access this. Any apps of these websites and satellite data resources that I use are totally free and available to the public. So if you want links for those, hit me up. I'll send them to you. I believe in sharing all this information and knowledge with everybody so you can do it yourself. So we start here with SDO, and we're looking at the sun in different images. There's different angstroms of light. That's 193, and this is 211. Those are two primary ones we're looking at. So what we look for is we look for dark patches like this that are equatorial because this is the same plane as Earth. So the forces coming out of these coronal holes are going to affect the interplanetary magnetic fields, or IMFs for short, of Earth. It gets a little more complicated than that, so I'm not going to go into too much detail of the explanations of how all this stuff works and why and all that. I'm just going to go through just to run you through the process so you could actually see the process, do it yourself, and then later on, once you have the process down, you can go in and start asking questions and trying to understand all the details and why it's significant and why it's so accurate and why it works and all that stuff. So anyways, try not to talk too much. So here it goes. So coronal hole, this is what we're looking at. We're looking for dark patches on this website right here that are about here. Once they get to this vertical center line and this horizontal center line, that means that they will be affecting the Earth, because these satellites are facing directly from the sun or towards the sun from Earth. So that's the first thing we look at. So we know the forces from these two things are going to trigger earthquakes. It takes anywhere from 1 to 3 days for these forces to arrive to Earth because of such, the vast distance between here and there, and it travels at different speeds. So it's hard to narrow down like by the hour when exactly. So I usually say something like today or tomorrow should start seeing some seismic increases. So it's not quite in the center yet, but it's pretty close. So you'll see it turn in from this area over here and come over here, and then once it's about here, it'll be at about peak power that will be affecting Earth. So we start there. Okay, so we know that this is going to trigger some large seismic events, meaning earthquakes at a 6 magnitude or higher, or a volcano. Only 6 magnitude or higher is statistically relevant. If you get into 5 magnitude earthquakes, there's literally like 3 of those a day on average. It doesn't mean there's 3 every day, but if you take the total amount per year and divide it by the number of days in a year, it's usually about 3 to 5 per day. We can go over that later. So we know this is going to trigger, or very likely, like in the 80-90 percentile, going to trigger a large earthquake somewhere on the Earth. So next thing, it's not really necessary, but I like to do this. I like to go to gong.nso.edu. And this is basically a model. It's not like an actual streaming of data. It's a model based on mathematical formulas and stuff like that. And it gives us an idea of these blue areas are the sun's corona. And the areas where you don't see the blue, that's a coronal hole. So this coronal hole we're looking at, whenever you see green, that means it's of positive electromagnetic influence. So it's an extension of the solar polar field. It's a positive electromagnetic influence. Not too big of a thing, but I like to look at that. So then how do we know where these things are likely to occur? So we're going to go to these next two right here. This is you can go to PSL, which is a physical sciences laboratory.noaa.gov. NOAA is the National Oceanic something administration. NOAA covers a vast array of different data sets and information you can get. It's a pretty cool site. Anyways, this is the daily OLR anomaly. OLR stands for outgoing long wave radiation, and basically that's slow moving radiation waves that are emanating upward from the Earth's surface or its lithosphere into the atmosphere. And I'll explain why that's relevant later. But you want to look for these areas of dark, like dark red. They're a lot stronger. You know what I mean? Some of these dark brown areas, that's again, the brown is a positive electromagnetic influence. The red is the is the negative electromagnetic influence. So we want to look for OLR anomalies that are near plate boundaries. And you can see plate boundaries if you go to earthquake.usgs.gov. Kind of zoom out a little bit. These red lines right here are plate boundaries all over the Earth. So whenever we see a couple things, plate boundaries, just keep that in your mind. So we're looking for two things near plate boundaries. We're looking for the outgoing long wave radiation anomalies. That's a collection of particles that have been gathering up and emanating upward from the Earth towards the atmosphere. And then what we do is we come over here to earth.nullschool.net. This is another free resource I use a lot to forecast this stuff. If you click this little menu down here, you go to, where is it? MSLP, I believe it, yeah, mean sea level pressure. That's what that stands for. So we switch to that map. It looks like this. And then what we see are these gray areas. You see gray, yellow, and purple. So gray are the high pressure cells. Yellow is kind of like the midway point. And then the dark purple, those are the low pressure cells. And the reason why this is important is because we have those forces coming from the sun, from space, coming in through all the layers of the Earth's atmospheres, compressing those layers and pushing charged particles downward. And what they tend to do is that they travel through these high pressure cells right here, like in the gray. They travel down here and they go into these low pressure cells. And then when these low pressure cells connect with these OLR anomalies, that kind of completes the circuit, if you will. There's a global electric circuit. We can go over that later, but that's basically, charged particles coming down from space and in through the atmospheric layers, down all the way to the lithosphere, which is actually like the surface and, like the outer layers of the actual Earth, the land itself. And then it slowly moves upward. So it's kind of a circular thing. It's the global electric circuit. So we get charged particles from space coming into high pressure cells, coming down into these low pressure cells. And we're looking for areas where they connect with these OLR anomalies that are traveling upward. If you can kind of picture that. I'll try to make some animations on how that looks later so you can get a better idea. So we look at these areas. We look at these areas right here too, where there's some OLR anomalies and other areas where we see these low pressure cells, because the low pressure cells are going to be bringing in all these charged particles from the upper atmospheric layers down into the lower atmospheric layers. So, so here we have some low pressure cells, some big ones, near plate boundaries. Let me move this over here. There's some plate boundaries right here. This is like northern India going down into Pakistan, near Afghanistan and Iran and stuff like that. So what we see here in northern India, we see it's a lot of low pressure cell, but if we zoom in a little bit, there's not a lot of movement, except maybe for right here. And right here, there's a lot of movement. It's like Saudi Arabia, I think. So there's other things to look at, but when I look at this right here, I feel like this is going to be a strong area to watch for seismic activity. Looking right here where all this pressure flow is going. And this could all change over the next few days. That's why it's tricky to do these forecasts, because things change over time. So where you might have a strong low pressure cell, by the time those forces from the sun arrive, that low pressure cell might not be as powerful, it might not be there, or it might be somewhere else. So at the moment, I would look right at this area. And if we zoom in right there, that's, that's basically, southern Iran, Pakistan, Afghanistan area. So that's one of the first locations I would put on the watch. There's parts of the world where these types of events, like big earthquakes and stuff, essentially, they happen a lot. And so those are kind of like the usual suspects, if you will, of places where you'll see some seismic activity. So let's go back here, zoom out a little bit, go down here. And Valdez looks right here. See, this is very tiny low pressure cell area right here. So like there's earthquakes here that are major ones that happen, a lot more often than in other parts of the world. This one right here, we'll come back to that in a second, but I see this one right here, and I believe this is like Papua New Guinea. So I would say Papua New Guinea, and probably even like these southern Indonesia islands right here. That'd be another location for something major in the next few days. We go down to this area right here. See, this is kind of a big one, and this is kind of powerful too. There's a lot of forces going in there right now. So this area, I believe this is Tonga and Fiji. This is, I want to say Vanuatu, but let's be sure. So, no, that's New Caledonia. There are earthquakes that happen there quite often, so that wouldn't be surprising. So we also have Samoa, Fiji, and maybe the Tonga area, but let's just be sure here. So Fiji's up here. Again, this low pressure cell could move. I don't know what direction it's going to move. I don't keep up with that stuff. And then we have, some stuff offshore of New Zealand right there, but that's, and it's kind of near this plate boundary. So that's, a possibility too. Let's look at the OLR again. The OLR is kind of hard to see in this view. So yeah, maybe there's a big one right there. But these little speckles of one right there. That's why I said the southern Indonesia islands and up here in like Papua New Guinea is likely. Now let's move upward a little bit more here to Japan. So Japan, zoom out. Yep. So as of now, I would definitely say southern Japan should be on the watch too. Japan gets a lot of earthquakes. I'm sure some of you know. If you don't know, now you know. And there is an OLR anomaly right there in southern Japan too. So I would put that on the list of, higher potential for a large seismic event, an earthquake at 6 magnitude or higher. Predicting 5 magnitude and lower is, again, like I mentioned, it's not statistically relevant, and quite frankly, it's asinine in my opinion. I don't do that. 6 magnitude. It has to be 6 magnitude or higher. It doesn't matter. You could put a blindfold on and throw a dart at any day on a calendar, and there's a good chance that a 5 magnitude earthquake will happen on that day. So, you get these other streamers and people out there saying, oh, this 4 magnitude. Oh, yeah, I could see something 5 magnitude or 4 magnitude. It's like, yeah, okay, you're probably right, because that happens almost every day. Anyways, back to the forecasting here. So then we see this right here. And it's another thing I tend to look out for is whenever we see a strong, like red color next to a strong brown color. That's usually a sign of something too. Not always, but it has proven to be, a high risk area for, a large magnitude event. You figure they're of reverse or, polar opposites electromagnetically speaking. So I would say, Southern America, Central Mexico, and there's already some activity there. So I would say, anywhere between Guatemala, that's kind of deep too. 4 magnitude events and lower are, and even 5, they are significant for predicting larger events if they're deep enough. So like if they're less than 10 kilometers, that's just a default when they don't know how deep it is. Anytime you see 10.0, that's just they haven't measured how deep it is, so they don't know. But like something like 20 kilometers, not very deep. And, and it has to be, I would say, a 4 magnitude or higher. And if you see 4 magnitude events like this, right? So it could be deeper, it could be deeper. When you see 4 magnitude events at 60 kilometers or deeper, that is, it's common that that is a precursor to a larger event. So I would keep eyes in this general region right here because these are all 4 magnitude events. And again, this is a default, so it might be deeper. Um, Nicaragua, Guatemala, those areas. And then we see this little cluster right here. Zoom in on that. See how they're all 10 kilometers? It's because they don't have an accurate measurement of how deep it is. So I would say there's definitely something building up right there, somewhere near Guadalajara. I'd say middle Mexico, and then this area right here. Definitely keep an eye on that area for major events. And let's go to my neck of the woods here. That's interesting. And I'll just throw this out there. The U.S. West Coast, this whole area right here is very difficult to predict. It sucks because I've lived here my whole life and I wish I could be as accurate here as I am with the rest of the world. I did nail the last major earthquake we had here about 7 years ago. It was out in the Searles Valley, I believe. I predicted that one about 4 days before it happened. I put out a long paragraph about it, but if there could be another one here, and I dread the day we hit a 6 magnitude here, and it didn't show up on any of my forecasts, or I just wasn't paying attention because I've been doing this for over a decade now. I got very high accuracy. I'm really proud of what I do, and it would just suck so bad if I couldn't do that in my home area. It's my biggest fear about doing all this is not nailing this area right here. So, anyways, and this is why it's hard, is because these plate boundaries are relatively shallow. So you're never going to see like anything 100 kilometers or deeper. And that's something we would normally look for in other parts of the world as being like a precursor to a larger event. Precursors here could be much more shallower. That's one of the reasons it's a little more difficult for me to nail these down. But let's look at the mean sea level pressure. See, we got some low pressure cells coming up here, kind of creeping up here. Not very powerful, but they're probably just sitting around here. If anything, I would almost say that Northern California is probably at a slightly higher risk, but not too much going on up there, or on the U.S. West Coast. If we look at the OLR, you see there is an OLR anomaly right there. I don't know if you can see it. It's not too powerful, and that looks like central to Northern California area. So I would say about a medium risk, and for the next few days, and that's that. So moving on, I don't really do Europe too much. Ooh, look at that. All right, let's check the OLR in that area. So, possibly. So let's look at this. What part of the area is that? Is that near Italy there? So, no, that's not Italy. Hold on. Sorry, I'm not geographically fluent. So that's Greece-ish. And then, what is this area right there? That's Ukraine. That, yeah, that would be terrible. Not like, I mean, yeah, that would suck. So, yeah, Ukraine area, I think, right? Am I crazy? No, right in the middle of Ukraine. Not a lot going on in Ukraine these days, so that would be exciting for them, I suppose. Totally joking, by the way. And that's about this. Maybe this is, what is this, Spain? No. Oh, yeah, that's Italy. Italy is interesting. Some of the worst volcanoes in the world, or one of the worst volcanoes in the world, is in Italy. One of the most troublesome ones. So this anomaly right here, if it moves over towards Italy. You might see something in Italy. Yeah, see that? And then that is southern France. This is like, these are the islands. And so, yeah, that's about it for now. Got some activity here. Could be a precursor to a larger event in Tajikistan. Do see earthquakes there once in a while. There's a little cluster right here in Taiwan. Taiwan just had a major 7.5 magnitude a few weeks ago. I forecasted that one as well about 2 days before it happened. And so that's about it. It's going to be lasting throughout the end of next week. I think the hot spots we're looking at are this general area right here, maybe northern India, but probably more likely this area right here, like southern Iran, Pakistan, or Afghanistan. We got southern Japan as of now, maybe some bigger activity in Taiwan. See, how deep is this right here? Yeah, see, that's deep. We get a couple more deep ones like that in the next couple of days. There could be a big one right in this area. Southern Indonesia, that area. And right here, just east of New Zealand. And then this area right here, I have, yeah, I'd say this area right here. Middle Mexico. This is southern Mexico, Central America, this area right here. Nicaragua up into central Mexico. I believe there's two different areas going on here. We got this little cluster right here. This is looking like it really something bigger is going to happen there in the next couple days. I would say this is number 1 or 2 on my list. It's hard to rank these and say which one's at the highest risk, but definitely of the ones that are of the highest risk, I would say this region right here, southern Japan, New Caledonia, southern Indonesia, and this area in the Middle East right here. So that's about it for now. This is the total electron content, all in South America right there. So look at South America real quick. This area gets a lot of earthquakes too. Not seeing anything too significant there right now. But again, this could all change in a couple days, and maybe I'll check in. Ooh, yeah. Maybe I'll check in later if this moves inward just a little bit. You could see some activity there, and this is the Chile region. I said I was going to keep this short, and I am, so I think that's about it. If you guys have any questions or anything, or you want to hit me up, just let me know, and I'll answer your questions. So there it is. See y'all later.